In this lesson, we're going to learn how to multiply and divide fractions. Now, you may have noticed that we're introducing multiplying and dividing fractions before, say, adding and subtracting fractions. That is because, surprisingly, multiplying and dividing fractions is actually much easier than adding and subtracting fractions. So, for this reason, we're going to introduce you to multiplying and dividing fractions first. So when it comes to multiplying fractions, it is actually quite easy. It's just simply that we multiply straight across. So if you have fraction a divided by b multiplied by c divided by d, it is just simply a times c over b times d. And you might think that seems incredibly simple. Well, hopefully you're thinking that. Well, the truth is, it is. So say, for example, we have negative 12 divided by 5 multiplied by negative 20x. So you might think, okay, well, why are we doing this? Because we have a whole number, we even have some x's in this. This doesn't seem quite as simple as just multiplying fractions. Well, that's because we're going to introduce some new concepts integrated into multiplying and dividing fractions. So we have 12 divided by 5, negative 12 divided by 5 multiplied by negative 20. Well, we recall that negative 20, well, that is just equal to negative 20 divided by 1. So when it comes to multiplying fractions, you can think of whole numbers as that number over 1. So the next thing we need to realize, okay, we go back to our multiplication rules. We have two negatives multiplied by each other. So whatever our answer will be, it will be positive because same side sign gives us positive. And now we just multiply straight across. So 12 times 20x, that would be 140x. Excuse me. Bad math there. 240x. That's my bad. 240x is what the top will be, and the bottom, again, just multiply straight across. That is 5. And now that we've multiplied the fractions, now we just have a normal fraction, and like normal, we want to find it in simplified form. So how we do that, again, it is finding the prime factorization. So that's 2 and 120, 2 and 60, 2 and 30, 2 and 15, and then 3 and 5. So that's prime factorization of 240. And then 5 is simply 1 and 5. So like normal, we put them on top of each other. So that would be 2 times 2 times 2 times 2 times 3 times 5. And then we can't forget our x that is also in here. So we can just put a times x at the end, all divided by 5. So like normal, we just cross out common factors. And this all equals 2 times 2 times 2 times 2 times 3 times x, which is just simply 48x. So negative 12 divided by 5 multiplied by negative 20x is just simply equal to 48x. And that is how you multiply fractions, like I said, just straight across. So I'll give you guys an example to work on here. So your example is 11 divided by 3 multiplied by a negative 9x divided by 7. I'll let you work on that right now. Okay, so like I said, we just multiply straight across. So 11. So we see that we have a positive times a negative. So our final answer is going to be negative. 11 times 9x, well, that's 99x. 3 times 7, that is 21. And now we find our prime factorizations. That's 3 and 33, 3 and 11. We have 3 and 7. So we go 3 times 11 times x, because we can't forget that x up here, all over 3 times 7, and again it is a negative because we determined a positive negative. It's going to give us a negative. Well, we're going to cross out 3, so that is 33x divided by 7. So hopefully you came up with the answer to 11 divided by 3 multiplied by negative 9x divided by 7 is equal to 33x over 7. And again, that is how you multiply fractions. You just simply set them both up in a fraction form, whether it's a whole number and put it over 1, or if it's just a regular fraction and just multiply straight across. Dividing fractions is a little bit different. So, to divide fractions, we have to find what is called the reciprocal. So I'm going to introduce the idea of a reciprocal. The reciprocal of a number is what that number needs to be multiplied by to get to 1. In most cases, it is the inverted version of the fraction. So, let's say that might sound a little confusing. So let's say we have 10 divided by 3. Well, 10 divided by 3 multiplied by what gives us 1? Well, the way we find that is like this says, just simply in most cases is the inverted version of the fraction. So in this case, 10 divided by 3 multiplied by 3 divided by 10 is equal to, well, 30 over 30, which is equal to 1. That's what we're looking for. So the reciprocal of 10 over 3 is 3 over 10. Likewise, say we have a whole number like 9. 9 times what gives us 1? Well, it's the exact same thing. It is the inverted version of the fraction. Well, this isn't a fraction, it's a whole number. Like we said, we can always put it over 1. So 9 divided by 1 multiplied by invert the fraction. 1 divided by 9. 9 divided by 9 is equal to 1. So the idea is you have to be able to find the reciprocal, and again, the reciprocal of any number is what gets us multiplied by each other to get 1. And in most cases, that is just the inverted version of the fraction. So that is what is called the reciprocal of a number. So why do we care about the reciprocal of a number to divide fractions? Well, we'll walk through an example and see why. So imagine you have a fraction of negative 7 divided by 8 divided by negative 14 divided by 27. Okay, so note that this is the exact same thing as saying negative 7 divided by 8 divided by negative 14 divided by 27. So why do we care about the reciprocal? Well, the way to find the answer to this fraction is just simply multiply the top of the fraction by the reciprocal of the bottom. So that would look like 7 divided by 8 multiplied by the reciprocal of the bottom. Again, the reciprocal is just the inverted fraction, so 27 divided by 14. Again, to divide fractions, you just multiply the top by the reciprocal of the bottom. And now it's just like we talked about when it comes to multiplying fractions. By 14. Okay, so just like normal, we have a negative and a negative, so we know our final answer is going to be positive. So we have what is 7 multiplied by 27. Again, in a lot of cases, you guys might want to pull out a calculator to calculate this, which I'm doing right now, which is equal to 189. And then 8 times by 14 is equal to 112. So that is it. Now we just want to find the simplified version of it. So that would be 3 and 63, 7 and 9, 3 and 3, and then now we find the prime factorization of 112, which is 2 and 56, 2 and 23, 2 and 28, 2 and 14, 2 and 7, so we'll stack those on top of each other, so 3 multiplied by 7, multiplied by 3, multiplied by 3, all over 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 7. And again, we know this is positive, so we can just leave it as is. So now we cross out common factors. That's it. So 3 times 3 times 3 is 27. 2 times 2 times 2 times 2, well, that's 4, 8, 16. So the answer to what is negative 7 divided by 8 divided by negative 14 divided by 27 is 27 over 16. And again, the way we found that was we set it up in a fraction form. We multiplied the top by the reciprocal of the bottom. We multiplied those, got this number. We simplified that fraction by finding the prime factorizations of the top and the bottom, cross out common factors, and we come up with this answer. So that is how you divide fractions, and I'll give you guys an example to work on so you can try this yourself. So now I'm going to use a couple of variables and see if you can figure those out. So p divided by 2 divided by pq over 8. Now again, you can just treat these variables just like they were a regular whole number, okay? So I'll let you guys work on that, and then we'll go through it in a minute. Okay, so again, how do we set this up? Well, we know that p divided by 2, this is the exact same as saying pq divided by 8. And now we just simply multiply the top by the reciprocal of the bottom, so that is p divided by 2 multiplied by the reciprocal, which is 8 over pq. And now we just multiply straight across, so we have 8p multiplied by pq2. I'll do that the other way around, make it a little bit simpler. 2pq. And now, before we even find the prime factorizations, we can just look at this as, you know, they already have some common factors, which are p. So we can just cross p straight out because it's in both the top and the bottom. So now we have 8 over 2q. Well, 8 divided by 2, that would be 4 over q. And again, that's just because we pulled a 2 out of the top and 2 out of the bottom. So the answer to p divided by 2, or the fraction p over 2 divided by pq over 8, is 4q.